Our next topic is solving trigonometric equations. And there are a set of smallish, basic trigonometric equations which you need to know how to solve without reference to a calculator, without reference to any other device. You just need to have it in your mind. So I'm going to show you the way to solve some of these basic, just the stripped down, fundamental trigonometric equations. This is the way I learned it when I took trigonometry way back in 1930, and this is the way I do it still to this day. So there are a couple things you need to have in mind, a couple pictures that are going to be extremely helpful here. The first, well, these are in no particular order, but one of them is you need to have in your mind the basic sine curve and the basic cosine curve. Just this basic structure here. So we know this is 0, we know this is pi, we know this is 2 pi. The maximum is pi over 2, the minimum is 3 pi over 2. We know this is 0, pi over 2, pi, 3 pi over 2, and 2 pi. The other two pieces we need to have in our mind are this is 1, this is 1/2, this is square root 3 over 2, and then this is the 45, 45, 90 triangle, and this is square root of 2, this is 1, this is 1. Now, one thing to bear in mind about a triangle is any triangle is similar to any other triangle where the sides are in proportion. What that means is this triangle and this triangle, for the purposes that we're solving, they are equivalent. You may, if you wish, and there are certain times where this comes in handy, you may double all these numbers. Multiply this by 2, multiply this by 2, multiply this by 2. The 2's cancel. Sometimes it's more convenient to think of it in this way. Sometimes it's more convenient to think of it in this way. Now, I don't have both of those in my mind's eye. What I have is this one in my mind's eye. And recognize that you don't need the 2. You don't need the 2. But if you throw out these 2, you need to double this. This needs to become a 2. So you could see this as 2 and 1 and square root of 3. Or you could see it as 1, 1/2, and root 3 over 2. It just depends upon what you need for your particular problem. All right? If you have those three pictures in mind, then solving these equations, the basic fundamental equations aren't going to be particularly challenging. The little equations become pretty straightforward to solve. What we need to remember, among other things, let's see, we also know this. This is our little memory device for what quadrants the various angles, various functions are positive and negative. All right? So we have that in mind. And we also have the wonderful memory device, SOHCAHTOA. Right? If we have all these things in mind, again, if you don't have these in your mind's eye, you probably haven't gotten this far in trigonometry in the first place. So all of those pieces are rummaging around your mind. The question is, can you harness them and then use those to advantage when you're solving these equations? Really, to solve these equations, really, that's the point of all this stuff in the first place. Everything we've done so far has been really channeling toward this notion of solving these equations. So, solving trig equations. There are several steps in mind, but one thing we're going to have to bear in mind, somewhere in this process, we're going to need to do a quadrant check. I'm going to expand on this sequencing a little later, but for now, there needs to be a quadrant check, and there needs to be reference angle. Quadrant check and reference angle. Now, let's review reference angle for a moment. Suppose we have theta reference, and again, I'm going to pick a number out of the blue sky. Suppose our reference angle is 15 degrees. Let's do this in degrees this time. Okay, so what is theta in each of these four quadrants? Well, in quadrant 1, theta reference is theta. So this is theta reference, and theta is the same in quadrant 1. So theta is 15 degrees in quadrant 1. In quadrant 2, this is theta reference, but that's theta. So if this is 15 degrees, the angle we're looking for is the 180 subtract off the 15. So in quadrant 2, 180 minus 15 is the 165 degree. That's theta, right? Now let's draw a new picture here. In quadrant 3, there's theta reference. And we want this larger angle. So that's the 180 add on the 15 degrees. That's 195 degrees. And then finally, in quadrant 4, there's theta reference. Theta reference always lies against the x-axis. Theta reference never lies against the y-axis. Theta reference always lies against the x-axis. So this is the right angle. Theta reference is 15 degrees. So what is that? That's almost one complete revolution, but you back off the 15. So 360 minus the 15, what is that? 345, 45, is that right? Right? So that's the 360 minus the 15. So that's in degrees. We could do a similar thing with radians, but theta reference lies against the x-axis, not the y-axis. Maybe it's worth our while to review this same notion here, the reference angles with a radian measure. Let's suppose theta, and let's use one we're going to typically be using here. Suppose theta reference works out to be pi over 3. All right? So what is that in the various quadrants? I'll draw a separate picture for each of the 4 quadrants this time. Well, in quadrant 1, if this is pi over 3, well, we know in quadrant 1, theta reference is equal to theta. So theta here is pi over 3. In quadrant 1, theta reference is equal to theta. In quadrant 2, if this is pi over 3, then that's the angle we want, which is half revolution. So this is pi minus, so this is theta, pi minus pi over 3. That's 3/3 minus 2/3. I'm sorry, 3/3 minus 1/3 is 2/3 pi. In quadrant 3, there is pi over 3. We now want that piece, right? So this is theta, this is pi add on, so this is pi plus pi over 3. 3/3 plus 1/3 is 4/3. And then finally, in quadrant 4, this is pi over 3. And so this is the angle we're seeking. This is now 2 pi, almost one complete revolution, but you subtract off. So this is now 2 pi minus pi over 3. 6/3 minus 1/3. So theta is 5/3, 5 pi over 3. And so we're going to do a quadrant check. That's going to incorporate this idea. And then we're going to do a reference angle. We have to find the reference angle. And then once we know the quadrant check and the reference angle, we use this notion to find the actual solutions we're seeking. So that's sort of an introductory start. What you need to have in your mind, at the very least, you need to have written down on the paper you're going to be using. But at the very least, in your mind, you need to have this piece of information, the graph of the sine and cosine, these 2 basic triangles. You need to know SOHCAHTOA, and then we should be and know these reference angle families, and then we should be able to. It should be good to go.